in terms of training your flight crew and in a space-like environment, but not a fully orbital environment, and not unlike what NASA does with high-performance aircraft. So this is an approach we'll take through our development and preparation for orbital flight.
Sure. And one of our key acquisitions was Chris Ferguson, who was the last space shuttle commander. So he is on our team and responsible for crew and mission operations, and he is defining not only the crew requirements but also the selection process.
From our perspective, our flight program is being run by Steve Lindsay. Steve is a 5-time shuttle pilot and former chief of the astronaut office, and because our vehicle is a lifting body piloted vehicle that has very direct similarities to the shuttle, there is a significant pool of people who have experience in that regard that we can draw on.
And at SpaceX, we're just starting internal discussions about how we're going to select crews for those first couple flights. So I don't have a definite answer for you, but I can tell you that since you made it personal, I did not come to SpaceX specifically with the number one priority of going back into space. If that was my number one goal, I would have stayed at NASA in the astronaut office and had opportunity to fly again to the space station. So what's important to me is not that I get to be the guy that flies on this vehicle. What's important to me is that I can look myself in the mirror, look at my wife and my son, and say to them that the risk is acceptable for me to fly. So that it's not important that I go, but I have to be willing to go, because I'm not strapping somebody else into it if I'm not willing to strap into it myself.
If I could add, though, I think everyone here, if I know the people that come to work at commercial space companies, I think there's probably no shortage of people that will want to sign up and fly on any of our vehicles in those early flights. So.
Okay, next online, and I apologize if I get your name wrong, but is it Veronique LaCapra from NPR? Sounds like somebody is not muted on the phone bridge. Veronique, are you there? Okay, let's move on to Ed Grosberg from Flight International. Ed?
Okay.
How about,
sorry, no questions at this time.
Okay, I'm sorry, who was that?
This is Veronique, and I have no questions at this time. Thank you.
Okay, thank you, Veronique. How about Ed Grosberg from Flight International?
There's no Ed, but there is a Zach. I have no questions at this time.
Oh, okay, Zach, welcome. Go ahead. Oh, no questions? Okay. Michael Belfari from Popular Mechanics. How about Ken Kramer?
Hi, thank you. Yes, I'm here. First, good luck to everyone in getting American astronauts back in space as soon as possible. I have two quick questions for Mark and for Garrett. Garrett, please, can you tell us, you talked a little bit about resolving the engine problem, hopefully. Are you aiming for a March 1st flight of the next mission, or what is the target? And for Mark Sarangelo, talk a little bit more about that flight test article, what that would involve. Do you intend to launch that on an Atlas, and how close would it be to the actual vehicle? Thank you.
So yes, I'll go ahead first and say, as far as our next launch of the Cargo Dragon to the space station, yes, it's on schedule for an early March launch here out of Cape Canaveral, and we don't see right now any issues that would hold that up.
Thanks for the question. Our flight test vehicle is a full-size vehicle. The outer mold line and the perimeter of the vehicle is exactly what we would be sending to orbit. It's not outfitted for orbital flight. It is outfitted for atmospheric flight test. And the best way to provide analogy, it's very similar to what NASA did in the shuttle program with the Enterprise, creating a vehicle that would allow it to do significant flight tests, whose design then would filter into the final vehicle for orbital flight.
Ken, anything else?
Oh, well, I could ask Boeing a question if there is time. How close are you actually to cutting metal? And for Ed Mango, why are NASA astronauts not allowed on these test flights? Thanks.
See, was the first question about when we're going to cut metal? Who was that to?
I think that was for Boeing. First question on when we're cut metal. I think our first piece of flight design hardware will be delivered to KSC in the old OPF-3 within 5 months.
See, your other question was about NASA crew, and so at this point, what I'll say is under ICAP. If you remember a chart I had the two circles. One was public purpose, one was a NASA mission purpose. Under ICAP, that is really the transition, that is really mostly public purpose. And because we want our industry partners to develop a capability that they can use to go to destinations in low Earth orbit, we would like them to get to a point where they're ready to put their crew on their vehicle at their risk. And so it changes the dynamic a little bit when normally under a contract, the contractor comes forward and says he's ready to go fly, but it's a NASA individual that's going to sit on a rocket, so it becomes a NASA risk. What we did is we flipped it around under ICAP. That's not what we're going to do long-term under Phase 2, but we flipped that around under ICAP and said, we want to know when you're ready to fly your crew and put your people at risk. And that then becomes something that we were able to evaluate under ICAP. So I would say also, I think Garrett said it very well, in the end, all of our partners want to fly safe. They're not going to take any shortcuts on flying safe. They are going to try to figure out how to go do that the best way they can. And so all of us have the same initiative, and it doesn't matter who's sitting on top of the vehicle. It's a person, and that person needs to fly safely and get back home to their family. So that's the mission of all our folks on this panel and all of our industry partners, is to figure out how to get someone to fly. It doesn't matter if they're wearing a blue suit or a company suit, how they get back to landing and go back to see their family.
Okay, and I believe we have one more on the phone bridge from Eric Good. Eric, are you there? Eric? Okay, well, we're back here. Before we pick up any follow-up questions, we do have one that we received via Twitter on Ask NASA, and it's from Pat Host with Defense Daily. What are the specific safety requirements and standards that have to be reached for certification?
Well, see, this is Ed Mango. How I would answer that is if you look at our web page, and we can get you that afterwards, it has all of our requirements listed. There's roughly about 300 of them. They are safety requirements. Examples would be we have to be able to fly with a fault-tolerant scenario that says if you were to lose a particular system, you have a backup system in order to get the crew through the rest of the mission safely. That would be the kind of requirements we have. Another one would be that during an abort, we have to be able to get the crew back to the surface safely. I think in the video that Sierra Nevada showed, they said no black zones. That's what we like to call it, I guess, in vernacular. But in reality, it's want to make sure that we can get the crew back to the surface and survive that all the way down to the surface on any abort scenario. We also have other performance requirements, which is we need to get the ISS for our mission. We need to provide 4 crew to the International Space Station. The vehicle needs to be docked to the International Space Station for up to 210 days and be able to leave at any time in order to get back home, either for an emergency to get back home or at the end of that particular mission. So those are the kind of requirements. Now again, there's a couple hundred of them, and you can go online and get all those at our website. And all those have been defined, all been baselined. All the companies have them. They've had them since August. And so everyone is working towards the same set of requirements, and we don't expect to change them. We went through a great extent of trying to make sure we understood them, and we gave them out to industry, and now we're moving forward. And so that's what we expect the companies to try to meet, and when they have a better way of doing it, then they'll bring forward their variances, and we'll talk about those.
Okay, and we also just received a Twitter question from Alan Boyle from NBC, who was with us on the phone bridge. He wants to know, does Sierra Nevada have a crewed flight plan? They're planning suborbital flights first, question mark.
Yes, we do. Our vehicle is what we like to call optionally piloted, which means it's fully autonomous and fully piloted from its design. And so too does the flight test program alternate between autonomous flights and crewed flights. And we will be going through the suborbital regime to get to orbital flight, and we will be doing that in both autonomous as well as crewed versions.
Okay, thank you. All right, we're back here at Kennedy. Do we have any follow-up questions? Seeing none, I want to thank you all very much and turn it over to Mr. Mango for some closing remarks.
Okay, thanks. And I definitely want to thank everyone for coming out to Florida. It's probably the warmest day I've ever seen in January, so thanks for coming to Chamber of Commerce Florida Day. I would say that the couple questions about crews and who they are, and I think I tried to answer that earlier about to us it does matter who's on top of the vehicle for a particular mission. When we're in our test flight phase, whether it's under ICAP, it will be crews from the companies. Under phase 2, it will be probably combined crews between what NASA needs as well as what the company might want to do, and we'll have to go talk about all those details. But in the end, this is a joint effort between our astronaut corps and the astronauts or the crew members that the individual companies might be hiring. And it's that joint test plan that would get us to an end state. It isn't just one or the other. If anyone has developed aircraft in the past, you know that it's military pilots as well as pilots from the companies that do the flight testing. And so we expect that same kind of approach as we move through this overall process of trying to get developed. I'd also say it is important to talk about those blue suiters or company pilots that are flying the vehicles. But I would also say, just like in STS-1 in 1981, there were 2 pilots flying that vehicle, 2 test pilots. They took an awful lot of risk on that particular mission, but there were thousands, if not tens of thousands, of people behind there to make sure the vehicle was going to fly safe and the first test flight was going to be successful. It's no different than in this generation of human spaceflight endeavor that we're proceeding with. There'll be a couple people that are sitting on top of the vehicle, ready to fly the vehicle, but there'll be hundreds, if not thousands of people that are engineers, technicians, mechanics, quality folks that are behind the 2 people or 4 people that are sitting on top of the vehicle to go fly, that are going to make sure that the vehicle is as safe as possible to go fly. That is an American endeavor. That is a national interest. That is a national involvement to go make this happen. It's not just about the 2. It's about the hundreds of people that want to see America get back into space and have a transportation system to do so to low Earth orbit. Thanks for coming today, and thanks for listening, and y'all have a good day.
All right, thank you. And a reminder, you can stay up to date on the exciting progress of the Commercial Crew Program in several ways. On the web at www.nasa.gov/commercialcrew, on Twitter @commercialcrew, and on Facebook @NASA Commercial Crew. Thank you once again, and have a great day.